Now to continue the starting from the explanation about the functions after the event and the modifier. So actually the UI is what is going to look like this. So let's sign in. So this is what we are actually going to develop, and also the dark and light mode is also enabled. So now to continue it, the functions out here, you can see that the next first function is creating the project, then the next is donating to the project, or let's say donating to that campaign or donating to that crowdfunding project. So now the syntax in the Solidity is, now you have to write like a function, this a keyword, then the name of the function, create project. So in this says create project, so we are creating the campaign or we are creating the project. So this is what going to be look like in the UI at a later phase. So the syntax is create project, then you can see the string memory of the title, then description, then target, and the deadline. So now why this memory is being used out here is this memory, because these parameters are strings which are actually dynamic types. So using memory indicates that, or shows that, or specifies that the data of creating project, the data exists temporarily only for the execution, only during the execution of the function, and actually it doesn't go beyond, or doesn't persist after the function call ends. So that's why it is memory. That means it stays, or it is meant provisionally for this function only. Then you can see the target and the deadline. So I'll explain why it is underscore, then title, then description, then target and deadline. So next is the public, then returns, and the in the UN 256. So the public is actually a keyword, which means that the function is accessible to anyone. So anyone who wants to raise the fund, for creating the project, so it's accessible to that. It shows, so by making it a public, it shows, or it allows external users to interact with the smart contract and, let's say, invoke this function. Then next is now public, then returns of UN 256, meaning that this functions is going to return the ID of the newly created project or the campaign, where it will serve as ID. That ID will serve as a unique reference for the project in the project mappings that was actually coded out here. So that is the return part of UN 256. Now next is the require. We can see that now in order to create a project, what we need to have is, we need to ensure that the deadline should be greater than the blocked or timestamp, which is the current timestamp. So require is a keyword in Solidity programming language, meaning that it functions like a if-else statement, or like, let's say, like switch statement in JavaScript. So it says the require that the deadline should be greater than blocked or timestamp. So that is definitely that the campaign or the project that should be in the future, so it cannot be the current date. And next is the about the storage design. So project is equal to projects of number of projects. This line of code is actually one way confusing, but to put it in a simple way, this project is actually the name of the variable given when the project is being created. So which means these functions, the functions modifies the project mappings which resides in storage. So project storage of this, the project storage of project is equal to projects or number of projects, means that it creates a reference. While creating the project, it's meant only for this function, but while the project is given as a variable name out here, so when the project is being created, it's being added to the number of projects to the mappings that was actually done out here. That's the meaning. So next is now the project dot owner is of course the whoever created the project, that is msg.sender. Then title is of course the underscore title, then description of the project description, the target how much the target actually aiming to raise, how many Ethereum you are going to raise, then the deadline, then amount collected, how much Ethereum you have collected, and project dot is successful is currently set to false because that is yet to be project is yet to be created. I mean yet to be, why project is created, so the tenure of that project is yet to be completed, so that way it's default to false, same as for refunded. Then next is, as I said earlier, for the event which was created out here, event on project created. So once while this event is going to log details creating the transparency, so it needs to be emitted. So out here you can see the project created, number of projects, and what you need to emit is the title and the target, and also the number of projects returning the number of projects issued, it will be plus plus. Now the next confusing part is returning the number of projects -1. So why it is that? So technically from the technically why this number of projects -1 is best because of zero based indexing in Solidity. Because zero based, we call it zero based indexing. So where the projects actually starts from 0, while the current project will be at here in this projects of 0. When it is incremented, so it will be set to 1. But that is not a correct. That's not a correct status of the project. So it has to be subtracted. So that's why, and same as now. Let's say a project. Okay, let's projects 1. So it has to be subtracted -1, meaning that if you return the number of projects, actually directly the result would be 1, but actual project was stored at index 0, starting from 0, so the return ID would be then would be incorrect. So that is why the second project is stored in project 1. Suppose the number of projects incremented to 2, but returning number of project would give 2, but the project was actually stored at index 1. So that is why, in order to give it correctly, that is why return number of projects is -1, because it is indexing, zero based indexing, where the project starts from projects of 0. That is why, that's the main reason. So otherwise we are going to give the wrong data. I mean not wrong information out here. Then next function is the donating to the project, or the donating to the project, or let's say contribution to the project or to the campaign. So now you can see that they were donating to project UN256 ID public payable, and then the next is UN256 amount, which is the MSG dot value. So now this in Solidity, the ID parameters out here, ID parameters identifies, let's say identify the project being donated to, or identify the campaign that you are creating, or some kind of contribution. That's where the ID parameters actually identifies it. So it is necessary to assess the corresponding project in the project mapping. And next is public. Yes, it should be public, because anyone who are willing to contribute can do a contribution. And then next is payable. So this is interesting part. Now if we do not use the keyword payable, now this whole set of project will collapse, because you want to be able to receive the donations. you weren't able to receive the contributions, so that is why it's payable. So by marking this function as a payable, it allows to receive the ether from the users. So without this payable modifier, the function cannot accept the donations or the contributions from the users. And next is now amount is set to msg dot value. Now next is, as explained above, it's same, because we cannot allow the users to contribute more than, the negative figure. So that is why the amount of the contributions that the users are going to make, it should be always greater than 0. And also same as that, this line of code is also shows that while the variable where under this project, when donation is being made, so it should be, it should the specific project that was mapped above, and its id should be allotted. And that's where the what that's where the actually the donations is going to be made. And also it ensures that this line of code is ensure that the changes made to the project's contributors and contributions are persistent. Then next is the now when you donate the project, so once the deadline is over, so the block to timestamp should be less than the project dot the deadline. So you cannot donate the Ethereum. You cannot donate the Ethereum after the deadline. So that is some kind of checking and check control. And then next is after this many set of conditions where you are not allowed to contribute more than less than the 0 amount, and also about the deadline. So next is now, after fulfilling this condition, next is now project.contributors.push. We are pushing the msg.sender. So what this actually does is, now we are having some kind of out here why push for the contributors and contributions. So that is, it actually appends the contributors address and donation amount to their respective areas in the project stock. So this will I would say allow the tracking the source and size of every donation made. So at last we will going to get the project.amount collected, which is the amount set above. Now after that now we are going to the event that was used out here now, the donation received. So now this has to be emitted. So it is now this line of code, what it will do is, now it will log the donation on chain, so specifying the project id, then msg.sender, or the contributors address and the donation amount. So mainly for the transparency and for tracking the contributions. And that is what it's all about for these two functions. Now to say a little bit about there are different types of data location in the Solidity smart contract or Solidity programming language. You can see that memory is being used out here. Which is for used for the function arguments that needed only to provisionally or for temporary purpose. And also the reason is because this actually helps in reducing the gas cost compared to storage. And also, like, next is we can also in advanced level we can also use the call data. Then before the start of the next function, I want to say that you can see that out here the underscore title, the end descriptions, so it's being used. So by using that, this underscore title, so underscore title, then deadline and description. So it used to, I mean, the what to simplify, it says like something like it is actually used to initialize the, like suppose like title, so it is going to initialize the title field of the project struct of this. And and also, also why it is being used like this is because to avoid some kind of naming conflicts. So between these functions, between the functions, I mean arguments and the state variables that are being given above. So that's the main reason. So now what I want to say out here is, now these two set of functions are now functions. What it does is, now it's creating the project, and after the function, after the project is being created, after the campaign is being created, then next is now users are going to donate. So now after the donate part is done, so next which I'm going to explain is about now while this project is being created, now we need to finalize this, we need to set certain conditions. While project is created, now we need to finalize it. So there are other set of functions after that too, so which I'm going to explain in detail. The next function is now the finalizing project, followed by the refunding back to the contributors, and also the fetching the details of those who actually has made contributions, or those who have actually contributed. So out here, function finalize project, then unit 6 of the ID, then public, then only owner of that ID. So now what this function is now trying to do is, now these functions can be only be called by the project owner, only owner, where we actually have set the modifier at the top, only owner, because we do not want, if Mr. X actually raised the project or created the project or raised the campaign, so we won't allow the Mr. Y to modify it or finalize the project. So that is totally illogical. So now explain above, the next line of code is project, referring to the struct above. So this line of code, as I said earlier, what it does is actually it creates a reference to the specific project in the blockchain storage, so that allows the direct, I mean I would say like direct read and write access to its data, so using the project's ID. So it's like graving the exact project file from a filing cabinet and having the ability to modify its content directly. So that is what this line of code does. So now when we, after the project has been created, now next project, the condition is, so when you finalize the project, so we need to ensure the deadline has been met. This line of code is what actually does block.timestamp greater than equal to project.deadline. So now next, the next is if the amount collected meets or actually exceeds the target. So now if the project.amount collected is greater than equal to project.target, then that's considered to be successful. So now next is the if the amount, I mean this line of code. So now what this line of code now does is, now so if the it has used the dot call method to send ether. So that's the modern Solidity practice, where it requires the transfer to be successful. So now this line of code ensure that after the amount has been raised and deadline over and all the set of conditions are being fulfilled. So this line out here, you can see that keyword payable. Now payable of project.owner.call, meaning that the fund that has been contributed raised is now, it has to be sent back to the creator of that project. So basically it transfer the entire collected amount to the project who actually created it. So that is what this line of code actually does. So if it is not, then it is, if it's not successful, then it is false. Then at last the emit of project finalize, where ID of that project dot success. The successful, meaning that it actually emits an event with the project ID and the status of that project, whether it is successful or not. So now the next stage is now, if the project is not successful. So if the project is not successful, and if there were no contributors, then if target has not been achieved, so whatever amount of Ethereum it has collected, so it has to go back to the contributors. So this functions is what actually it does. So this function returns the amount contributed by the contributors back due to the reason that if due to some conditions where you can see out here. So this line of code is same as explained above. So now when we refund, the block.timestamp should be greater than equal to project.deadline, meaning that the only after the deadline is over. And also the refund is that this condition is now after deadline is over, and if the target is not achieved, then it definitely, and if the project is not successful. If the project is not successful, of course, if the project is successful, we cannot refund. If the project is not successful, then you have to refund back. So this line of code is what actually does. Then also same for this also same for this, where the refund must not have been already processed. So now next line of the code is the for loop. This for loop, so what it does is it actually, to explain one by one. So first is in the for loop, there is always some kind of, I would say, initialization, then certain conditions, then increment. So initialization un256i is equal to 0. So start the loop, it is starting the loop counter at 0, meaning that it allows us to iterate, through the entire contributors array. So there are a list of contributors. So the condition is I is less than project.contributors.length, meaning that it continue as long as I is less than total number of contributors. So that ensures we actually iterate over every single contributor. So if there were 10 contributors, then this function is going to, this loop is going to iterate over the 10 contributors for the project that was not being successful, and that's where we are going to refund it. Then the increment, so after each iteration, so increment I by I plus plus. After each iteration, so you are going to increment I by 1. So that is what actually code says. And the next is, so it moves to the next contributor in the array. So next is address contributors is equal to project.contributors of that I, where it actually retrieves the address of the current contributor, and where this I actually acts as an index to assess each contributor. The next is un256 contribution amount is equal to project.contributions of I. So now this line of code is actually, what it does is actually it gets the exact amount the current contributor actually has donated. So if the contributor has donated to let's say 0.3 Ethereum, so this line of code is what it's actually trying to find out. So index I, project.contributions of index I, ensures that actually we match the contributor with their specific the contribution made. And next is this line of code. After iterating over the set of contributors and finding out the total amount of contribution they made, next is, now because this function is going to refund back to the contributors, so now next is, after finding the total amount they have contributed, next line of code, what it does is actually, this is sending back the Ethereum back to the contributors. So it is going to exact contribution amount. So you can payable of contributor dot call, meaning the modern the sending Ether of practice. so where it sends ether back to the contributor, and ensure that the refund was successful. So if refund is, then if any refund fails, the entire transaction is will be, what to say, will be reverted, or will be terminated, will be cancelled. And next is now for these functions, now that the event is going to be emitted out here, the refund issued, ID of contributor and contribution amount, ID of that contributor, and along with the contribution amount made. So what this line of code does is, so it is creating an event for each refund. So by this line of code we can find out which project was actually refunded, to whom, to which set of contributors the contribution were actually refunded, and how much amount was also refunded. So that is what this line of code is actually doing. So to summarize, what it says is, now the loops ensures that every single contributors actually gets refunded because the project being created by the owner or whoever actually created the project was unsuccessful. And also the contributors and contributions allow some kind of precise matching. So we need to find out exactly the amount of the Ethereum that was the contributors actually has contributed. So this is what actually this line of code actually it does. So to say it again, so firstly, it ensures that the project owners can actually finalize their own projects, and also protects the contributors by providing the refund mechanism, and also through the event, it ensures there's transparency in tracking the contributions. And also the refund contributors functions played a role where the amount of Ethereum that they have contributed is going to be refunded back because the project was not successful. So now the next function is now function get contributors of. Now this function, just few lines of code. Now what this function does is, now after the after the project is being finalized, now we are going to fetch the details of those contributors, who were the actually contributors. Now public view returns, because it's public and it's also view for readable part, and where everybody can and anyone can call it. So address of being that it is a set of arrays of address being stored in data memory, and also the you can see that the UN256 area of the memory, and what we are returning the project ID dot contributors and the project ID of the contributions. We are returning the contributors details and the amount of contribution made by the contributors. So this is what this actually function does out here. After fetching the contributors details, then next is the fetching the project itself, the function get project. So you can name as you like. So you can give it any type of name. So I have given like a function get project, or get campaign, or get the project details, something like that. So what this function is doing is, now it's public view returning the details of the project. So you can see that address string memory, so there is repetitions. But what this address does is, it's all about the project dot owner, whoever actually has raised the project or created the project. Then this one is string title and a description, then followed by the target. Then we have the deadline, then amount collected, and whether it's successful or not, and whether it's refunded, and also fetching the details of the contributors and the amount collected. So when this function is being called, so it's going to pull out and return all the project owners, or the address of the project owner, then the title, then the description, then the funding target, then the deadline, the amount collected so far, and whether the project was successful or not, and whether the refunds have been processed or not, and also the complete the list of contributors, and this I wish this which actually matching a detailed list of exactly how much each actually contributions was made. So this is what is going to this is what actually this function is going to do. So next is the withdraw funds. So if we really look into the code, so this is rather the a duplication of project finalized one, because out here when you finalize the project after meeting all the conditions, then whatever amount there is being sent back to the contributors. So for this, so I will remove this one withdraw function. I'll remove this one. So now next is about the extending the deadline of the project. So sometimes we may come across where the project deadline of the project will have to be increased, or I mean not increased, will have to be deadline has to be postponed. So these functions now, what this function is trying to do is now this function is now trying to set the postpone the date, so where only the owner can do it, so only owner of that ID, and where the new deadline has to be deadline in the future. So whatever the new deadline should be beyond the deadline given in the earlier stage. And also the project should not be successful. So if the project were successful, there is no reason to even extend the deadline. And also the project storage. So now I have explained this one above. So basically that project, it refers to the struct above of that variable storage given the name as project. So this project is actually the struct type actually defined in the smart contract out here, this one. Then this project actually, it contains all the properties of a project, so like title, description, and so on and so forth. And next we can see this keyword storage, a solidity storage keyword, which I've said earlier that meaning that when we create a reference to the actual data store in the blockchain's permanent storage. So compared to memory, so changes made to the project, unlike memory, changes made to the project will actually directly modify the stored data. So that means we are not creating any kind of copy, so rather we are getting a direct reference to the project that is being there in the project's mapping. So this project is actually the variable name, so we are actually using to when we interact with a specific project, where it allows us to read and modify the project's properties directly or easily. And the project's ID is where actually this is where the assessing a specific project from the project's mapping, so using the project's ID. So when you create a project, we will have the ID of that project, and that's where it's going to retrieve the exact the project instance when you actually finalize the project, I mean when you create the project. And next is now the canceling the project. So next function is canceling the project. So that is only the owner can actually cancel the project. The reason is while the reason can be any or can be many, but out here the condition is, I mean the when the owner can cancel the project is, I mean the when the before the deadline is over, so before the arrival of deadline, so we can cancel the project. And also if the project is not successful, but you can see that out here the refund contributors functions is being called. So meaning that this is some like I would say like an emergency exit strategy for the project owners, so where it actually allows completely stopping a project so before the arrival of that specific deadline. So only the project owner can cancel the project, and can be done before the deadline, but it cannot cancel the successful project. And while calling this cancel project, it will also call the refund contributors, which is actually here, the refund contributors function. So when calling that cancel project, it will also call this function. So without fulfilling that, without fulfilling that, so it will not work. So it automatically triggers the this refund contributors function, and after that the project will be then the marked as a refunded is set to be 2, and also the deadline is equal to block dot timestamp. Only after that many conditions are being fulfilled, the cancelling of project it will work. Otherwise it will not work as coded and intended. So next is the about the updating the project information. So we can update the project information, but that can be only the owner can do it. So this line of code is same as above. Now updating the project of information is now that can be updated before. So if you want to give a new description and new title and the content, if you want to improve the content, then you can update, but the condition is that the block to timestamp should be less than the project or deadline. So the deadline should not be over. And after that, so what we are going to have is we will have the project title of new title and the description of that new description. So this line of code is what actually it does. Firstly, it fetches the details of the project, then it allows the owner to extend the project, and also the updating the project information, where the owner is given certain the SS authority to update the project's title and the description. So in the next part, so I'll explain about the active part and their other set of functions which are actually necessary for the crowdfunding smart contract. So whatever may be, so I'm explaining the smart contract for this crowdfunding smart contract. So at the dark mode it looks like this, and at the white mode the project, the UI looks like this. So this is what we are going to build it. So any kind of lapse, any kind of missing part, or any kind of functionalities that doesn't work, so what we are going to improve it. And after that, the most important part is, after that we are going to deploy to Valsal. The next is about fetching the active projects. So active projects, get active projects, then the check refund status, and get funding progress. Like out here you can see the funding progress. So the first active projects, it is going to filters and returns all the active projects as a temporary array in the memory, and where the checking the check refund status is going to verify if a contributor is eligible for refund by checking the project status and the contributor's presence. And last one is this get to the funding progress. Funding progress is going to calculate and returns the funding progress of a project as a percentage, so ensuring the integral accuracy. So the first is, now out here you can see the get active projects. Name of the function is get active projects, and its public view returns is going to return the project of array of that memory, meaning that is a declaration of array of project structs that was defined above, stored in a memory. So it specifies that array will be stored to memory temporarily in a memory, rather than in the blockchain storage that was given in the above the struct. because the memory is cheaper in gas costs compared to storage, and is also most appropriate in this context. So now there are next is two loop. There are two loops out here. At the beginning, the active count is set to 0. So now what this for loop is doing is, now this loop actually counts the number of active projects. But also what I want to say is, now this loop actually also define what considered to be the active projects. Number one is that the current time, that's the block dot time stamp, is should be the before the deadline. That means deadline is not yet over, and the project that is not marked as successful either due to deadline is not over or whatsoever. So that two are the main the main factors that actually define the meaning of actually the active. So to explain it further, so out here you can UN256 I is equal to 0, I less than number of projects, meaning that it ensures the loop actually iterates through all the projects starting from 0 to what we call the number of projects that we actually has initialized to 0 at the beginning. And also the block dot timestamp block dot timestamp is less than projects dot deadline, and that checks if the current time is before the project's deadlines. And also second one is, what this code says is, it ensures that the project has actually not reached its funding goal. And at last the active counter plus plus, where increment the counter. So if both conditions in the above are true, so the counter the active count is actually be increased by plus plus, meaning increased by 1. And so by the end of this for loop, so active count will actually is going to hold the total number of active projects that is being created. And next is now the project of array. The memory active projects is equal to new project of array of that active count. So meaning that a new array named this active projects is created in memory temporarily with a size equal to the active count of above. So why this array was created? Because it's going to store all the active projects, so that will be later returned by these functions. So that means this memory is being used to store the active projects. So that is what it actually, this function, this loop is actually doing. This array is actually what it does. So there are two set of loops. First loop is going to return the hold the number of active projects, meaning in the sense that it's going to determine the size of active projects array, so avoiding the over allocation of the size and and the memory. Now second is, you can also find the the second the second loop, same as above, but little different, where at the beginning the index is set to the 0. So starting is that, as explained above, it ensures the loop is actually iterates through all the projects, and also check if the project same as above, the condition is same as above. But the addition out here is, now after the one more condition is that, now when the project actually meets the criteria of mentioned above, so it is stored in the active projects array at the position of index, meaning that while the first loop is going to determine the size of the active projects array, the second loop, what it does, it is actually populating the array with the actual project data. So that means without knowing the active count, people hand number of active projects, so creating the appropriately sized array at a later part will be tough. So that's why there are two loops being used out here. So after adding a project to the array, so indexed variables is being increased by 1 plus plus, so ensuring that next active project is added to the next position in the array. So that is what this for loop is actually it does. And and by end of this, so the active project array is then fully populated with all active projects, and the index the index variable equals the active count. So though it's no longer being in use after the loop, so that is what actually this function is actually trying to. First it actually define the what is that active project mean, then the first loop determines the size of the active project array to in order to avoid the over allocating of memory, which actually to prevent, I mean, the usage of gas. While the second loop, especially this line of code, second loop is actually it populates the array with the actual project data. And next is now the function of checking the refund status. So this line of code is also very simple. So it iterates over all the contributors, and it's checking that whether that contributors is actually a genuine. I mean, it checks it is checking whether the contributors is a correct one or not. To Well, it verifies if a contributor is eligible for refund by checking the project status and the contributor's presence. So this loop is actually very simple and easy to understand. I see no requirement of the technical explanations. So and the next part, and so in the next part, the is all about the, as I have shown earlier, is about the showing the progress. So getting the fund progress. So public view returns unit 56, something like that. And then we are going to return the project dot amount collected into 100. So divided a project dot storage 100, because the Solidity actually doesn't accept the floating numbers. So that is why I have used it.
So in the earlier part, I have spoken about the get active projects function, then the check refund status, and also the get funding progress. So in the get check refund status, uh, the functions also about function. What it does is actually, if the contributor is found, the function checks two conditions. So this is what the loop actually does. It's very simple. So if the project is not successful, or if the project has not been refunded, then if both conditions are true, so the function returns true, indicating that the contributor is eligible for the refund. The next is the get funding progress, about displaying the progress of the project being created. So next is now the last function. Last function is the getting the top contributors. So these functions get top contributors determines and actually returns the top contributors to a project based on the contribution amount. So taking into two parameters. So one is the ID, the unique identifier of the project, that's underscore ID, and the underscore count. Count out here is the number of top contributors to return. And also what it does is it actually outputs two arrays. One is top contributors and another is the top contributions, the address of the top contributors and the corresponding contributions amount. And this line of code, as I explained earlier, so it does the same purpose. So next is the project, the I mean the unit 56, the num contributors is equal to project dot contributors dot length. So while this actually function assess the project specified by the ID from the project's mapping, So this it actually retrieves the total number of contributors called num contributors by checking the length of the contributors project.contributors.length by checking the length of the contributors array in the project, and then it determine and then it actually determine the return count. So the return count variable is the number of top contributors to return. So un6 of return count is equal to the underscore count less than number of num contributors. So if count is less than num contributors, return the only count. Otherwise, return all contributors or num contributors. This is the ternary operator type being applied out here. Then next is the address of array of memory, the contributors copy, and the unit 6 array of memory of contribution copies. So that is actually that these two lines of code, what it does is actually it copies these are the temporary arrays in the memory. So modifying this one actually doesn't affect the context, the smart context state. And whereas these top contributors and top contributions are also new arrays of size of the return count are part out here, so that will actually hold the result. But this doesn't modify the state of the smart contract itself. And now next is now the main purpose out here is now, because this function is get top contributors, so it is actually finding the top contributors. So who are actually contributing to, and who actually what was the amount contributed by that contributors. So the first is the you can see the for loop is being used into 56i is equal to 0, then I less than return count, then I plus plus. So it starts with the max index as 0 and iterates through all the contributors. So that is j is equal to 1, j is equal 1 to till the num contributors, and it searches for the contributors with the largest contribution by comparing each value in this the contributions copy with the current maximum. So if contributions copy of j is greater than contributions copy of max index, then max index is equal to j, meaning that if larger contribution is found, so the max index is updated to the point to that contributor. So because at the UI level, so all the recent the contributions, so the top contributors will be displayed at the later part. So if larger contribution is found, so as I said earlier, if larger contribution is found, then the max index is updated to the point of to that contributor. Then the last is top contributor of I is equal to contributor's copy of max index. So what this line of code does is the top contributors adds and then the contributions are added to top contributors and the top contributions. So the contribution as max index, you can see that contribution max index is contributions copy of max index is set to 0. So why it is contributions copy of max index is set to 0? Because while this loop is actually selecting the top contributors, we want to prevent from selecting the same contributors again. So same contributors again, and that's why their contributions value is now actually set to 0 out here. So we want to avoid selecting the same contributor again. That is why it is set to 0. Then last is actually it returns the top contributors and top contributions. So what I want to say from this the function smart contract step is that
these functions actually is trying to find out the contributors made to different projects and displayed. So with this, the with these functions called now get top contributors, the smart contract explanations comes to an end. While this is purely the for academic for learning purpose, it may have some kind of smart contract bugs or some kind of security flaws. So this is not advisable for deployment to the uh, mainnet or the mainnet, I mean the Ethereum blockchain. But this can be, I think this can be audited, and also you can implement the most better tested libraries like OpenZeppelin. However, from this smart contract, what I'm trying to do is, so I'm trying to convey the message of how we can actually build and develop this smart contract and interact with the front-end UI libraries and build full stack DeFi application. So with this the smart contract coding comes to an end. In the next part, what we will do is now while this smart contract has been written, so what we need is we now need hearted, we need the private keys, because those who deploy the smart contract, so when we I mean the when we deploy the smart contract to the Ethereum blockchain, we need to pay certain amount of gas fees, and then after that then only the UI part will be started. So thank you for watching.